Welcome to 3D single-shot video tutorial. This is the first of 3 videos during which we will learn how to set up a 3D simulation of single-shot induction hardening system using advanced geometry editor in Xenos. Each video will cover one of 3 parts of the simulation setup: geometry creation, meshing, and physics setup. Inductively hardened part, which we will demonstrate in these videos, is called an external grenade or a CV joint, which is mainly used in front-wheel drive vehicles as a torque transmission element between the transmission and the drive wheels. We have simplified the model for presentation purposes and taken out the splines and other elements of the part. In this video we will go through steps needed to prepare the CV joint geometry for meshing. We will import CAD of our system, create airbox around it, and partition and group it to name surfaces and volumes of our geometry. For this tutorial, we will use single-shot geometry from Xenos documentation page. Open it, find 3D single-shot tutorial, and in the beginning of it you will find a zip file which contains CAD in step format. Download it and extract step files so we could use it to create the simulation. We start by opening a new case in Xenos. Save it before starting any work to make sure you don't accidentally lose your progress. Choose the simulation creation approach and physics of your simulation. Click the folder icon to find and load the step file we just downloaded. After a few moments, Salom will open, where you will find your imported geometry. In Salom, Shaper module is automatically opened with the geometry we just imported. To zoom in on your geometry, click spacebar. As the CAD of our system is already created, we only need to make the airbox around it to finish the geometry building. First, we will create one side of the box, which we will then extrude into a full 3D volume. Because inductor terminals must be on the same plane as one of the airbox sides, click Sketch tool and create a sketch directly on one of the terminals. Set the sketch plane, position your geometry in the center of the screen and turn off the interaction style switch to be able to draw a rectangle in the sketch. Select Rectangle tool and with a free hand draw a rectangle around the geometry. If you have created the rectangle too small or too big, you can adjust the size and positioning of it by simply dragging the edges around. Close the sketch and turn on the interaction style switch. Select Extrusion function, click on the rectangle we just created and enter the extrusion height in the correct direction. Turn off the visibility of the sketch. Select the imported geometry and extruded airbox. Click Partition to join them together and create one single simulation domain. In Partition drop-down, rename parts of it to the corresponding volumes such as air, inductor and workpiece to ease the group creation later on. You don't necessarily need to do this, but it will be easier to find the specific partition volume from which you want to create your group if you have named it previously. Click the Group function. Select 3D selection and from Partition drop-down select Workpiece to add it to the group. Rename the group as Workpiece and click Apply and Continue. You now have created a separate volume group for Workpiece, which can be found in the Groups drop-down. In the same way, create groups for inductor, air and concentrators. When creating volume groups, you are essentially extracting and naming volumes of your simulation domain. In this step, we are dividing our simulation domain into smaller domains such as workpiece, inductor and air. These subdomains we will use to separately create mesh and define physics for each domain. Switch group selection to 2D. In Partition drop-down, enable the visibility of the inductor. Add one of the inductor terminals to the group and rename it as Terminal 1. You have now created a separate surface group for one of the inductor terminals, which you can find in the Groups drop-down with the rest of the volume groups. In the same way, create surface groups for the other terminal, workpiece surface and airbox sides. Surface groups are created to define boundary conditions on these separate surfaces. Boundary conditions are additional physical definitions for your simulation, which helps to correctly define electromagnetic field behavior, current flow, heat exchange, and other parameters. Note that if you want to select multiple objects in the preview window, hold Shift while selecting them. When you are finished creating each group, click Send to Geom icon to send partition and groups to Geom module in Salon. Geom is an alternative module for geometry creation, but because we have done everything in Shaper already, we will only use Geom as a transition from Shaper to Mesh module, as Shaper is not directly connected to the Mesh module. This concludes the first video about how to create and prepare geometry of a single-shot induction hardening system for meshing. Thanks for watching.